Now let's implement the AddItem method that will take the client as a pointer receiver. This will allow us to add an item to the inventory. So we will take a pointer to the item to add, and error if there are any errors when we attempt to add this item. First, we want to get a byte slice where we marshal the struct as JSON. So we use json.Marshal item. What this does is it takes this item pointer, which is a struct that contains ID, name, and price, and it converts it into JSON format. And it's important to note that this return of json.Marshal item is actually a JSON byte slice, and it holds the marshaled representation of the item struct. So think of it as item struct pointer to JSON byte slice. And the reason we do this is because we want to send a post request to the AddItem endpoint with JSON data. So if error does not equal to nil, then we can return fmt.errorf store can't encode AddItem %q because we want to add double quotes around the item ID. So AddItem request, and then we want to print the error as well. So item.id, for example, let's say the ID is like 45. It will get printed as 45 with double quotes because of this formatting verb %q. And we also want to pass it the error. So if the JSON marshaling succeeded and the item has been encoded to a JSON byte slice, then we want to actually make the HTTP post request. And HTTP post, we're taking that from the net/HTTP Go package. So it returns a response or a pointer to a HTTP response and also an error. http.post, the base URL is going to be c.url, which is from this client struct. And we want to concatenate this with /inventory/AddItem endpoint. And this is the target endpoint that the request will be sent. We're concatenating the base URL from the client struct with this actual endpoint. And this tells the server that we want to add this item to the inventory. And then the second field for the http.post request is the content type. So what is the type of data being sent in the request body? We're going to put application/JSON because the request body is going to have the JSON data that we marshaled from the item struct. And then the request body contains the actual data to be sent to the server, and we're going to use bytes.newReader and pass it in the JSON byte slice, which was the marshaled representation of the item. And the reason why we pass in the bytes.newReader and pass in the byte slice JSON representation into this new reader is because the post method from the net HTTP library actually requires that this third argument be an object that implements the IO reader interface. So third arg must implement the IO.reader interface. And this is so we remain compatible with http.request. And bytes.newReader may be confusing, but what it's actually doing is it's converting this byte slice that we pass in. So what is it taking? It's taking a byte slice, which is the result of marshaling the item struct into JSON. And what it's doing is it's converting it into a format that HTTP client can work with. So this third argument must be an object that implements the io.reader interface to enable reading of the request body. So using a reader for this third argument allows the HTTP client to read the data as it's needed instead of requiring the entire byte slice be stored in memory at once. And especially if there's a lot of data, we want to minimize the memory usage. And so this bytes not new reader is just allowing us to create a reader that can be used in lots of situations, not just for HTTP requests. That's just our current use case. And the reason for that is because it implements io.reader. And so hopefully that's a reasonable explanation as to why we are using bytes.newReader and passing in the JSON byte slice. And we want to check if there's an error. So if error does not equal to nil, then we return fmt.errorf store. We can't add item, again, %q, this formatting primitive, and we want to log the error as well. So item.id, which is going to be double quoted, as well as passing the error message. If this post request succeeds, we want to make sure that we defer the response body closing. This is going to ensure resource cleanup. After this function ends, this defer call is going to be made to release the response.body resources. Now we want to check the status code of this post operation. If response.statuscode does not equal http.status OK, which is the 200 status code, we want to try to read the response body, try to parse the response body, and see if we can provide more context that we can inject into the error message. So message error equals io.readAll, pass it the response body. If error does not equal nil, it means that we cannot parse the response body and we just return a very vanilla error message. So if error does not equal nil, we return fmt.errorf, and we have the inventory store got non-OK response, and we cannot read the body, which was supposed to give us more context to provide. So we have response.status as well as the error that we encountered when parsing the response.body. Otherwise, we do successfully parse the response.body using io.readAll, and so we return fmt.errorf store got non-OK response. And then we actually want to indicate the more detailed response.body. So we stringify the message that we got from reading the response.body. And otherwise, we can return nil because our AddItem has completed without any errors.